The Pacific Ocean at dawn is a cathedral of emptiness. Commander Tokishi Yamamoto stands in the conning tower of his I-boat, the I-176, his binoculars scanning an unbroken horizon. Nothing. Just the rhythmic roll of grey-green swells, the whisper of wind across the water, and the occasional cry of a seabird wheeling overhead. His crew has been monitoring radio frequencies for hours. Silence. Their hydrophones detect no propeller sounds, no ship engines, no convoy rumble. The ocean stretches out in every direction like a vast, indifferent mirror. Yamamoto lowers his binoculars and checks his watch. It's May 1944, and his patrol orders are clear: intercept American supply lines heading northwest from Hawaii. Intelligence reports suggested minimal air coverage this far out. They should be safe for at least another hour before diving. He lights a cigarette, lets the smoke drift away on the morning breeze. Around him, his lookouts relax slightly, shoulders loosening. One of them grins, says something about hot miso soup waiting below. Then the radar operator's voice crackles up from below, confused and urgent. "Commander, I'm picking up something." "No, wait, it's gone." Yamamoto frowns. Their own radar set is primitive, barely functional beyond a few miles. "What did you see?" he calls down. "I don't know, sir. Just interference. A ghost signal." 8 minutes later, the sky tears open. They come from beyond the curve of the Earth, Grumman Avengers, flying low and fast, already aligned for their attack run. There's no warning, no distant drone of engines building over time. One moment the horizon is empty. The next, death is screaming toward them at 200 miles per hour. Yamamoto barely has time to shout the dive order before the first bombs hit the water, geysers erupting where his submarine had been surfacing moments before. As the I-176 plunges into the dark safety of depth, Yamamoto's mind races. How? How did they know? His boat had been silent. No radio transmissions, no visible smoke, no wake. They were 300 miles from any charted American base. His lookouts had seen nothing, no patrol planes, no distant ships. It was as if the Americans had simply known. As if invisible eyes in the sky had been watching them the entire time, waiting, calculating, and then summoning the hunters with supernatural precision. Down in the crushing darkness, as his crew breathes hard and counts the seconds between depth charges, Yamamoto realizes something that chills him more than the enemy's bombs: the ocean is no longer empty. It's full of something he cannot see, cannot hear, and cannot understand. And that silence, that vast, terrible silence, isn't silent at all. To understand what Yamamoto couldn't see, we need to rewind the clock to a world where the idea of detecting aircraft with invisible waves sounded like science fiction. The year is 1935. In a cluttered laboratory in Britain, physicist Robert Watson Watt is conducting experiments that will reshape warfare forever. He's bouncing radio waves off objects and measuring the echoes that return. The concept is simple, almost absurdly so: if you can send out electromagnetic energy and catch its reflection, you can see things beyond the range of human eyes. By 1939, Britain had constructed Chain Home, a network of massive steel towers along their coastline, each one bristling with antennas that could detect incoming German bombers while they were still over the English Channel. For the first time in human history, defenders could see attackers before they arrived. Radar, radio detection and ranging had gone from laboratory curiosity to strategic lifeline in less than 5 years. The Americans watched, learned, and then obsessed. By 1941, US scientists and military planners were racing to build their own radar systems, improving on British designs, pushing for greater range, better resolution, more powerful transmitters. At MIT's Radiation Laboratory, engineers worked around the clock, fueled by coffee and the knowledge that every week of delay meant more ships sinking in the Atlantic, more planes falling from Pacific skies. But here's where the Pacific theater created a problem that European warfare never had to solve: distance. In Europe, you could defend Britain from France with radar stations 50 miles apart. You could protect convoys crossing the Atlantic with shore-based coverage supplemented by shipboard sets. The distances were vast, but manageable. The Pacific Ocean, however, was something else entirely, an aquatic desert stretching 7,000 miles from California to Japan, with only scattered island chains breaking up the emptiness. Early American radar in the Pacific was powerful, yes, but it was also trapped. Trapped on land. Trapped on ships that could only be in one place at a time. A carrier battle group sailing from Pearl Harbor to the Coral Sea moved through thousands of miles of what was essentially electromagnetic blindness. Once you left the protective umbrella of land base stations, you were navigating by hope and prayer, relying on scout planes that could only see a few hundred miles and submarines that might or might not report enemy positions before being sunk. Japan understood this weakness intimately. Their submarine fleet, sleek I-boats capable of crossing entire oceans, exploited these radar-blind zones with ruthless efficiency. They lurked in the gaps, the empty spaces between American coverage, striking convoys and vanishing before anyone knew they were there. The question haunting American strategists became increasingly desperate: how do you put eyes in the ocean itself? Admiral Ernest King stood in his Pentagon office in the winter of 1943, staring at a map of the Pacific that covered an entire wall. Red pins marked confirmed Japanese submarine attacks. Blue lines traced U.S. convoy routes. The problem was obvious, infuriating, and seemingly unsolvable. The red pins clustered in zones where the blue lines left radar coverage behind. A destroyer leaving San Diego might have land-based radar watching over it for 300 miles. Then nothing. Darkness. It sailed into electromagnetic silence, its own shipboard radar scanning frantically but only reaching to the horizon, maybe 25 miles on a clear day. A submarine could be stalking that destroyer from 40 miles away, staying just beyond detection range, using periscope observations to set up the perfect torpedo solution. By the time the destroyer's radar caught the sub's periscope, it would be too late. The numbers told a grim story. In 1942 alone, Japanese submarines sank over 60 Allied vessels in the Pacific. But the true cost wasn't just the ships, it was the psychological weight of sailing through thousands of miles of water knowing that death could be lurking just beyond your ability to see it. Convoy commanders slept in 4-hour shifts. Radar operators stared at their screens until their eyes burned, jumping at every false return, every wave crest that looked momentarily like a periscope. The Alaska convoys were particularly brutal. Supply ships heading north from Seattle to Anchorage had to transit waters where fog could reduce visibility to 50 feet, where storms could knock out radar equipment, and where Japanese I-boats could wait in patient ambush. One convoy commander later recalled the journey as sailing through a haunted house. You know something is in there with you, but you can't see it, can't hear it, can only wait for it to strike. Naval architects proposed elaborate solutions. Could they build ships with taller masts to extend radar range? Yes, but only by a few miles, and tall masts made ships top-heavy in storms. Could they deploy more patrol aircraft? Yes, but planes had limited range and couldn't stay aloft continuously. Could they station picket destroyers every 100 miles along convoy routes? The Navy didn't have enough destroyers in the entire Pacific to form a continuous chain. What they desperately needed, was something impossible: radar coverage in the middle of the ocean. Not on ships that moved, but fixed, permanent, reliable. They needed radar towers in places where no land existed. They needed to turn the ocean itself into an early warning system. In classified meetings at the Navy Department, engineers began sketching impossibilities. Floating platforms. Artificial islands. Anchored towers rising from the seafloor. The ideas ranged from ambitious to insane. But in total war, the line between insane and necessary becomes thin, sometimes invisible. By mid-1943, a small group of visionary officers and engineers had stopped asking whether such installations could be built and started asking how quickly they could be built. Because out in the Pacific, submarines were still hunting, and American sailors were still dying in the blind zones between radar coverage, sailors who had no idea that help, strange, unprecedented, almost magical help, was already being designed. The first sketch looked like something from a Jules Verne novel. A steel platform anchored to the ocean floor, rising 30 feet above the surface, topped with a rotating radar antenna and a small shelter for operators. Below the waves, concrete ballast blocks would hold it in place against storms. Above, a diesel generator would power the equipment, and a crew of 4 to 6 men would monitor the screens, transmit reports, and pray that the structure didn't collapse in the first typhoon. Commander William Key, one of the project's early advocates, presented the concept to a room full of skeptical admirals in Washington. "Gentlemen," he said, "we're proposing to build lighthouse-like structures in the open ocean, staff them with radar operators, and create a surveillance net that covers thousands of square miles of previously blind water." The silence that followed was deafening. Finally, one admiral asked the obvious question: how do you keep the Japanese from finding them and blowing them up? Key's answer was elegant in its simplicity: we build them where they're not looking. The key was understanding Japanese search patterns. Enemy reconnaissance aircraft flew predictable routes, scanning major shipping lanes and obvious strategic locations. But the vast empty zones between these routes, areas the Japanese considered too remote, too operationally insignificant to patrol regularly, those were perfect. Place a radar platform on a barely charted reef 200 miles from the nearest island, and Japanese aviators would fly right over it without noticing, assuming it was just another coral outcrop. The second brilliant innovation was the radar itself. Unlike conventional radar that broadcast powerful signals in all directions, signals that enemy receivers could detect and triangulate, these installations would use highly directional, narrow-beam radar. The transmission would be focused, concentrated, making it nearly impossible to detect unless you were directly in front of the antenna. And the signal itself would use frequency hopping and other electronic tricks that made it blend into the natural radio noise of the Pacific. To Japanese electronics, these towers would be silent. Invisible. Ghosts transmitting ghosts. But the engineering challenges were staggering. How do you build a stable platform in water that might be 50 feet deep one day and battered by 30-foot waves the next? How do you supply these stations when they're hundreds of miles from the nearest friendly base? How do you evacuate the crew if a typhoon approaches? What happens if the generator fails, or the radar breaks down, or a Japanese patrol stumbles across one by accident? The Navy turned to the one group crazy enough, skilled enough, and motivated enough to make this work: the CBs, Naval Construction Battalions. These were the men who had built airstrips on Guadalcanal while under artillery fire, who had constructed harbors from nothing but coral and steel, who treated the phrase "impossible engineering challenge" as a personal insult. If anyone could build towers in the middle of the Pacific Ocean, it was them. By autumn 1943, the first construction teams were shipping out to remote atolls with cargo holds full of steel pilings, concrete mixers, welding equipment, and prefabricated radar units. The project had a code name, Operation Silent Eye. And it was about to turn the Pacific Ocean into the most surveilled body of water in human history. Chief Petty Officer Robert Hutchins stepped off a landing craft onto what the maps called Marcus Reef, a spit of coral barely 200 yards long, located 500 miles from nowhere. The water was crystal blue, the air thick with salt and heat. Behind him, 3 barges wallowed in the swell, loaded with steel I-beams, cement bags, and a disassembled radar antenna that looked like a giant mechanical insect. His orders were simple and completely insane: build a functioning radar station here, make it storm-proof, and do it in less than 3 weeks before the next Japanese reconnaissance flight was scheduled to pass overhead. The CBs worked in shifts that blurred into one continuous marathon of welding, pouring concrete, and cursing equipment that constantly corroded in the salt air. They drove pilings deep into the coral, used underwater demolition techniques to level sections of reef, and constructed a platform that would sit just high enough above the waterline to survive storm surges but low enough to avoid detection from a distance. The design was intentionally crude-looking, deliberately weathered steel and barnacle-encrusted supports that, from the air, would appear to be old wreckage or natural rock formations. But beneath that camouflage was precision engineering. The radar unit itself was housed in a watertight shelter reinforced against wind and wave impact. The antenna rotated on bearings that had been specially treated to resist corrosion. The diesel generator sat in a compartment with backup fuel tanks that could keep the station operational for 30 days without resupply. And deep below the waterline, thick cables anchored the entire structure to concrete blocks weighing several tons each, creating an artificial root system that could withstand Pacific storms. Other installations went up on atolls so remote they didn't have names, just coordinates. One was built on a sandbar that only appeared at low tide. The Seabees constructed the base on stilts, creating a structure that seemed to float above the water. Another was hidden among the ruins of a Japanese seaplane base destroyed months earlier, the new American radar tower disguised as a remaining piece of the old wreckage. The Japanese flew over it twice without recognizing what it really was. Supply became an art form. Submarine chasers and PT boats would make high-speed runs under cover of darkness, delivering fuel, food, spare parts, and fresh radar operators. The crews manning these stations rotated every 2 weeks. Any longer, and the isolation, the constant ocean noise, and the psychological pressure of knowing they were sitting on an exposed platform hundreds of miles from help began to wear men down to dangerous fragility. By early 1944, a dozen stations were operational. By midsummer, 24. They formed an invisible fence across shipping lanes, submarine transit zones, and approach corridors that Japanese planners had considered safely beyond American surveillance. Each station could see roughly 150 miles in all directions under ideal conditions, creating overlapping bubbles of awareness that covered thousands of square miles of previously blind ocean. And the Japanese had no idea. Not yet. But Commander Yamamoto and others like him were about to collide with this new reality, and their confusion would mark the beginning of Japan's losing the crucial scouting war in the Pacific. Lieutenant Hiroshi Nakamura was keeping his own log, a private document that would never appear in official Imperial Navy records. His entries from June 1944 read like a descent into paranoia. June 12, surfaced at dawn, no contacts. Attacked by aircraft 11 minutes later, origin unknown. June 18, transmitted decoy signal per doctrine. American destroyers arrived within the hour. How? June 23, maintained complete radio silence for 72 hours. Still detected. Still hunted. There is something we do not understand. Across the Japanese submarine fleet, similar reports were accumulating. Commanders who had successfully hunted in these waters for years were suddenly being ambushed with unnerving precision. I-boat captains would surface to charge batteries in zones they knew were beyond American patrol ranges, only to find themselves under attack before they could crash dive. The timing was too consistent to be coincidence, too accurate to be luck. Japanese naval intelligence began analyzing the patterns. They considered the possibility of superior American radar, but their own technical experts insisted that shipboard radar couldn't reach beyond the horizon, and the attacks were happening in areas with no American vessels visible. They investigated whether American code breakers had penetrated their naval codes more deeply than suspected, but the attacks occurred even when submarines maintained absolute radio silence. They even entertained theories about American submarines acting as hidden scouts, but Japanese sonar operators reported no contacts before the aircraft arrived. What they couldn't conceive of was the truth that America had fundamentally changed the nature of the ocean battlefield. On July 4, 1944, the IA-185 surfaced 400 miles northeast of Midway to make repairs to a damaged periscope motor. Commander Suzuki personally supervised the work, confident in his position. His chart showed the nearest American base at least 6 hours away by aircraft, and his lookouts reported clear horizons in every direction. The sea was empty. The sky was empty. They should have been invisible. 17 minutes after surfacing, the lookout spotted aircraft inbound. Too late for a clean dive. Suzuki managed to get his boat under before the bombs arrived, but the depth charges that followed cracked hull plates and killed 2 men in the engine room. As they limped away, bleeding oil and losing depth control, Suzuki found himself staring at his charts in the red glow of emergency lighting. He drew a circle around his position and wrote a single word in the margin: impossible. That word appeared in more and more patrol reports throughout the summer and fall of 1944. Japanese submarine losses climbed steadily. Not because American weapons had improved, but because American eyes had multiplied. The ocean that had once offered endless hiding places was contracting, becoming transparent, as if some god had granted the Americans the ability to see through water and darkness and distance. In Tokyo, naval staff officers quietly began discussing the possibility that America had developed technology so advanced, so beyond Japan's current capabilities, that the submarine war might already be lost. They were right, but for reasons they couldn't articulate. The Americans hadn't just built better radar. They turned portions of the Pacific Ocean itself into a radar system. By October 1944, the statistics told a story that made Japanese naval planners physically ill. Submarine mission success rates had dropped by 60%. American convoys that should have been blind targets were evading Japanese patrol lines with suspicious accuracy. Allied carrier groups that previously needed constant aerial reconnaissance to locate threats were now maneuvering as if they had perfect intelligence on every enemy submarine within 500 miles. The psychological impact was even more devastating than the material losses. Japanese submariners, once confident hunters prowling the Pacific's vastness, now approached their patrol zones with dread. They knew something was watching them. They couldn't prove it, couldn't locate it, couldn't destroy it. But they knew. And that knowledge poisoned their effectiveness. American convoy losses dropped sharply. Ships that once sailed through enemy-infested waters in constant fear now traveled with confidence born from knowing they had invisible guardian angels scanning the horizon far ahead. When a submarine did approach, the warning came early enough for escorts to shift position, for aircraft to launch, for the prey to become the hunter. The strategic initiative in the Pacific submarine war reversed completely. Japanese boats that had once paralyzed American logistics were now being systematically hunted down. American submarines, meanwhile, began receiving targeting data from these same silent stations, coordinates where Japanese supply vessels were detected, positions where enemy patrol patterns showed gaps, intelligence that turned guesswork into precision strikes. In his final patrol report before the I-185 was lost with all hands in November 1944, Commander Suzuki wrote, "We are no longer fighting an enemy we can see. We are fighting an ocean that has become hostile to us. The Americans have turned the sea itself into their weapon, and we have no defense against water that watches." He was describing, without knowing it, the moment when technological asymmetry becomes psychological defeat. Japan submariners hadn't just lost their technical edge. They'd lost something more fundamental, the belief that the ocean could hide them. And without that belief, even the bravest crews became cautious, hesitant, ultimately ineffective. The radar towers themselves didn't survive long after the war ended. Most were dismantled, their steel reclaimed, their locations classified and then forgotten. A few rotted in place, becoming coral-encrusted monuments to a moment when humanity learned to put eyes in water. But the concept, the fundamental idea that oceans could be wired for surveillance, that didn't disappear. It evolved. In the 1950s, as the Cold War descended like a frozen curtain across the world, the U.S. Navy began deploying SOSUS, Sound Surveillance System. Underwater hydrophone arrays stretched across strategic ocean choke points, listening for Soviet submarines the way those radar towers had watched for Japanese ones. The technology changed from electromagnetic waves to acoustic sensors, but the philosophy remained identical: make the ocean transparent to your surveillance, opaque to your enemy's movements. By the 1970s, underwater cables carried not just sensor data but telecommunications, eventually becoming the fiber optic networks that now carry 95% of global internet traffic. The ocean floor became, and remains, one of the most densely monitored environments on Earth. Satellite radar can detect submarine wakes from space. Autonomous underwater drones patrol shipping lanes. The ocean that once represented the ultimate hiding place has become something closer to a surveilled highway system. Commander Yamamoto's confusion in 1944, his inability to comprehend how the Americans were seeing him, would be incomprehensible to modern naval officers. Today's submarine commanders operate with the full knowledge that the ocean is watched, listened to, and analyzed by systems that process more data in a second than entire World War II fleets could gather in a year. Those crude steel towers built by Seabees on forgotten reefs were more than tactical installations. They were prophecy. They were the first chapter in a story that transformed the 7/10 of Earth covered by water from unexplored wilderness into contested, monitored, and ultimately controlled space. Japan's shock in 1944 wasn't just about losing a battle. It was about witnessing the moment when the ocean stopped being empty and started being everywhere humanity was looking.